What we're doing now is changing tracks from series and sequences and starting to think about something called parametric curves. So let's think about an example where we have a little bug that is crawling around on an XY plane. So it starts somewhere and it kind of crawls around and it meanders back and forth and it goes all over the place. And we might want to know how to describe the motion of this bug using equations. The first thing we would notice here is that this thing is not a function, because if we do the vertical line test, this is not going to pass the vertical line test. There are lots of vertical lines that pass through multiple points on this curve. So this is not a function, so we can't write a function y equals f of x. So this is not going to be x squared or x cubed or anything like that. But we still want a way of describing the motion of this bug. And the way that we're going to do this is we're going to think about this bug moving along over time, which kind of makes sense because it was a bug that traveled over time. And we might say, okay, well, it started out at this point down here, and that was at time 0. Can we write a function that describes the x coordinate at that time and a separate function that describes the y coordinate? And do that, can we find a function that's going to do that for all times? So we're going to have two separate functions, one that tells me what the x coordinate is at a point, and another function that tells me what the y coordinate was at that time. So these two functions are going to be functions of a third variable. We usually call it t representing time a lot of the times. And so that would be saying, okay, well, after 3 seconds or something like that, the bug was at this point, this xy point. Can I write an equation that tells me the x point and the y point? Okay, so this idea is called the idea of thinking about parametric equations. So parametric equations are going to give us a pair of functions, one that gives us the x coordinate and one that gives us the y coordinate. These give us coordinates on our xy plane, and the curve that is traced out from parametric equations are called parametric curves. So let's jump in and try and sketch a parametric curve. So I've given you a pair of equations, an x equation and a y equation. So when I graph this, I'm going to graph this as a pair of points where this gives me the x coordinate and this gives me the y coordinate. The way that we're going to do this to get started is let's just plug in some values and then plot the points and see if we can figure out what happens. So I'm going to pick some values for t. T oftentimes represents time, but it doesn't have to. So we can plug in negative values for t. And if you think about what does a negative value of time mean, think about when you were born. For you, that's kind of the beginning of time. That's like your time 0. But time existed before you were born. So in your mind, that's negative time. And positive time would be time after you're born. So negative time makes sense. It's just time before some arbitrarily chose starting point. Okay, so let's just pick some values for t. So I'm going to pick maybe -2, -1, 0, 1, and 2, and see if this gives me an idea of what's happening in this curve. The y coordinate looks a little easier to plug numbers into, so I'm just going to be lazy and do that one first. So I'm going to have 1 minus t. So 1 minus 2 is going to give me +3. 1 minus -1 will give me +2. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is -1. Okay, so those are my y coordinates. My x values at 0 will be -1. 2 minus 1 is +1. 4 minus 1 is 3. So -2 times 2, that looks like -5. -1 minus 1, -3. Okay, so now we have to figure out how do we graph these. So what these are going to do is this is going to give me a pair of points. So I have the point -5, 3. So we're not at this point, we're not looking at the time values anymore. We're just looking at the x and y coordinates. -3, 2, -1, 1, 1, 0, and then 3, -1. Okay, so I have 1, 2, 3, 4, 5. 1, 2, 3. So this is my -5, 3. So this was at t equals -2. You don't usually have to include what the time value was. I'm just going to put it on there right now to remind ourselves what's going on. So then we have -3, 2, 3, 2. -1, 1, 1, 0. 3, -1. This looks like this is creating a line. So we're going to graph this line. Okay. And so if we think about this as a bug traveling along, the way that the bug moved was it's moving it's moving down this curve because as time increases, the bug is moving down. So this is a bug that just traveled in a straight line. This is a function. This equation could be represented by a function of y in terms of x, and we'll think about how we can write that as a function in class. But for now, we just want to think, okay, we have this pair of equations, we can graph a parametric curve. Those arrows that I put on there show the direction of motion. The direction of motion shows which way we move as time increases. So this is saying, if I started here, at t equals -2, as time increases to -1, I'm moving this way. So I'm going to put the arrows along there to show which way I moved. Think about this as you're showing which way your bug moved on the curve.